Hello everyone, my name is Aradhya Sharma and today I will be presenting a comparative study of two important machine learning classification algorithms, random forest and naive Bayes. Both of these algorithms belong to supervised learning and are widely used in real world applications such as spam detection, medical diagnosis, and fraud detection. In this presentation, I will explain how both algorithms work, their advantages and limitations, and finally demonstrate them using a simple dataset in Python. So let's get started. In this presentation, I will first introduce random forest, followed by naive Bayes, and then I will explain their working concepts, compare their performance, and finally show a practical implementation using code. Random forest is an ensemble learning algorithm, which means it combines multiple models to improve performance. Instead of relying on single decision trees, random forest builds multiple decision trees and combines their output to make a final prediction. Each tree is trained on a random subset of the data, and each split considers only a random subset of features. This randomness helps reduce overfitting and improves generalization. Finally, all trees vote and the majority prediction becomes the final output. Let's move forward. To understand this intuitively, imagine asking multiple experts for an opinion instead of relying on just one. Each expert may make mistakes, but collectively they provide a more reliable answer. Random forest uses a concept called Guinea impurity to decide how to split data at each node. The goal is to create groups where data points belongs to a single class. Some important parameters include number of trees, the maximum depth of each tree, and I need to specify more the trees the better, but it gets slower since there's more computational power needed. And also number of max features. And let's move on to naive Bayes. Naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It calculates the probability of a class given some features. The key assumptions here is that all the features are independent of each other. This is why it is called naive. Even though the assumption is not always true, the algorithm works surprisingly well in many cases. Here is the Bayes theorem with listed all the terms. There are multiple naive Bayes variants, one of them being Gaussian NB, multinomial NB, Bernoulli NB, and complement NB. Their features are listed here. Here's an example. In spam detection, we calculate probabilities of words appearing in spam or non spam emails. We multiply these probabilities and compare results. The class with the higher probability is selected as the prediction. Moving on, Random Forest provides high accuracy and handles complex data sets well, but it is slower and less interpretable. It handles missing values naturally. It is resistant to overfitting since there are multiple trees working on multiple subsets of data. It works for classification, also regression, and it also provides feature important scores. Naive Bayes, on the other hand, is extremely fast and simple, but may not perform well when features are dependent, since naive assumes independence. It is great for text classification, implementation, interpretation, and high dimensional data work. Comparison. Training speed. Random forest is extremely slow compared to naive Bayes. Prediction speed. Random forest is still slower than naive Bayes. Accuracy wise, random forest is way better in accuracy, but that is because of high computational power needed. That the reason behind the slow training and prediction speed. The accuracy for text is moderate, whereas for naive Bayes it's excellent. Interpretability, random forest is low, whereas naive Bayes is high. Since it's probabilistic, it's easier to understand for non. Feature correlation. Random forest handles features well, whereas naive Bayes is kind of struggles to handle it. Small datas can overfit for random forest, whereas for naive Bayes they work swimmingly. For large datasets, random forest is considered more accurate but kind of slow, whereas naive Bayes gives us the fastness and scalability. Missing data is handled well, by random forest, whereas for naive Bayes, we need to pre-process it since it's a probabilistic model. Best use case for random forest is tabular structured data, whereas for naive Bayes, it is text, NLP, and uh, spam filters. Here is a performance benchmark for both. You can see for iris, breast cancer, 20 news groups, spam email, and MNIST groups. You can see that naive Bayes for accuracy is extremely terrible for most cases, except for 20 news groups. It is extremely close in case of spam email and breast cancer classification, whereas it lacks in MNIST digits and iris. When to use which? If you have structured data, you will go for random forest. If high accuracy is critical and speed can be compromised, I would suggest that you go for random forest. If feature importance is needed, we'll head to random forest. If it is complex and we don't want to pre-process data, we can head to random forest. Whereas for spam detection, text detection, and when speed is extremely essential, we choose naive Bayes. We might even consider naive Bayes when there's a small training data or there's high dimensional features. Baseline model is needed for naive Bayes. You need to give it pre-processed data so that it can work on it. Key takeaways. Random forest is ensemble power. There's many trees, there's majority vote, there's high accuracy, robust, great for tabular data, but it is very slow. Naive Bayes is probabilistic speed. It has Bayes theorem, independence assumption, fast interpretable, and ideal for text. But none of them are universally better. If you ask me which one I would choose, you'll have to specify what is your use case before I make a suggestion to you. They can complement each other. You can use NB for a fast baseline, upgrade it to RF if accuracy matters more than speed. Here's the end of the presentation, but we'll now move on to the code demonstration. Here's the code example. To get this, you'll need a data set. In this data set, you can see I have taken a sample data set with 5 features and 1 target. I have selected them and imported them from sklearn library. In this implementation, I have created a dummy data set with 5 features and a binary target variable. Each row represents a data sample and the target indicates the class label. I first import required libraries such as pandas and sklearn. Then I create a dataset manually using features, values, and target labels. Next, I separate features and target variables. After that, I split the dataset into training sets using train test split. For naive Bayes, I initialize the Gaussian naive Bayes model. Then I train the model using the training data specified earlier. After training, I make predictions on the test data. Finally, I evaluate model using accuracy and classification report. As you can see in the terminal below, here's my naive Bayes accuracy and here's my naive Bayes report. The accuracy and all the weighted averages are extremely high because the data set is extremely small and I have taken it just for a sample. Now we move on to random forest. Now I initialize random forest classifier with 100 trees. I train it using the same training data, then I make predictions and evaluate performance. For comparison, finally I compare the accuracy of both models. Typically, random forest performs better on a structured dataset, while naive Bayes is faster, but here you won't see any difference because of smaller dataset as specified earlier. To conclude, both random forest and naive Bayes are powerful classification algorithms. Naive Bayes is simple, fast, and works well with small text or text based data. Random forest is more powerful and accurate, especially for complex datasets. Choosing the right algorithm depends on the problem and the dataset. Thank you so much for watching my presentation. Have a great day.